Alright guys, with a new chapter starting, this chapter is going to be on thermochemistry, and there's a couple different equations that we're going to look at in thermochemistry. In the first couple pages of notes, you're going to see kind of just some energy equations, some transfer of energy and things like that. But the one thing I want to draw your attention to is on slide number 11, the energy equation, delta E, that means the change in energy. Delta always means the change. The change in energy is equal to Q plus W. Okay, the Q stands for heat and the W stands for work. Both of these units are going to be in the units of joules. Joules is an energy unit. And so whenever we calculate heat or work, it's in joules, and so therefore delta E is also in the unit of joules. All right, so you can see in here, there's a couple things I do want to tell you. When it comes to heat, the Q value, sometimes Q can be positive and sometimes Q can actually be a negative Q value. Q is positive when heat is added or absorbed by the system. Okay, so you'll see that a lot of the times in these equations, you'll say that so much heat energy was put into, added, or absorbed by the system. That means that the heat would be a positive value. Heat is a negative value if heat is lost from the system. If it says it gave off heat, then we know that our Q value would have to be a negative value. When it comes to work, we can also have the same for work as we did for heat. Work can be positive and work can be negative. Work will be positive if work is done to the system. If work is done by the system, or if it says the system did the work, then that means our work value is negative because it's going to take away from the overall energy that that the system did. And so if the system does the work, it's obviously going to lose energy. Just if you yourself walk up a hill, you're going to lose energy as you walk up that hill. So again, work done by the system will end up being negative. The other equation that this unit talks about is work is equal to a negative pressure times the change in volume. Pressure is always in atmosphere units. And volume, the change in volume, would be the final volume minus the initial. And it is going to be in liters. And so if we have work calculated this way, it would be in the unit of liter atmospheres. Problem is, when we calculate energy, we want it to be in joules. And so if we are in liters of atmosphere, 1 liter atmosphere is equal to 101.3 joules. And that is located in your notes in case you forget that. If you ever have to transfer between liter atmosphere and joule, that conversion rate is there. So do keep that in mind. All right, so let's take a look at some of the problems on our first law of thermodynamic worksheet. This is the worksheet, the first worksheet after the notes. It's the one you're supposed to do that goes along with this. For these problems, 1 and 2 are very easy. You just add and subtract to get energy. So I'm not going to go over those problems with you, but I will go over problem number 3 with you. Problem number 3 says if a system has 50 joules of heat added to it and it does 70 joules of work, what is its change in energy? Remember, the change in energy is equal to Q plus W, so work and heat added together. And now the only thing we need to do is figure out whether our Q value is positive or negative and whether our work value is positive or negative. So if 50 joules of heat is added, that means that our Q value is going to be a positive Q value. It also says, though, that 70 joules of work is done by it. So it says it does 70 joules of work. If it's doing 70 joules of work, it's actually losing energy to the system. And so therefore that would be a negative value. So when I plug this into my equation, my Q value is positive, added to my negative 70 joules of work. And so I actually end up with a negative 20 joules for my change in energy. And that negative 20 joules is going to mean that we lost energy. is what that means, instead of gaining it. So we lost 20 joules of energy. All right, do the same for numbers 4 and 5. You just have to figure out whether they're positive or negative. So if you have any questions, always email. That's not a problem. And then also number 7, I think, is very much the same way. It's very straightforward. Just figure out whether, you know, work and heat are positive and negative, and then do the problems from there. Okay. For number 8, and I'm flipping through this as I'm doing this. For number 8, it's a little bit different. It's actually 2 separate equations for number 8. And so if we take a look at that, let me move my screen up. All right, so if we take a look at number 8, it says in step 1, the system absorbs 73 joules of heat while 35 joules of work is done on it. In step 2, the system absorbs 35 joules of heat while performing 72 joules of work itself. All right, so again, we're doing the same process. We're figuring out whether work and heat are positive and negative, and then we're going to add the 2 equations or 2 steps together. So for step number 1, you can see that the system absorbs 73 joules. Well, if it absorbs it, okay, that means it's going to be positive. So our Q value for the first one is positive. While 35 joules of work is done on it. Okay, so the 35 joules of work is being done to the system, not by the system, to the system. And so therefore our joules are also positive there. If we add those 2 things together, we're going to end up with 108 joules that is positive for our delta E for our first step. For step number 2, it says that the system absorbs 35 joules of heat. Well, if it's absorbing the heat, okay, that means it's going to be positive. And it says that it performs 72 joules of work. Well, if it is doing the work, then it's losing energy through that work. So that is going to be a negative value. And so if we do 35 plus a negative 72, that is going to give us negative 37 joules of energy. However, what they want us to do is put the 2 steps together, okay, to see. So we're going to add these 2 steps together to see how that comes out. And when we do that, we end up with 71 positive joules of energy that is gained. Okay, so our change in energy is going to be positive, so we've gained 71 joules of energy. Problem number 9, this is going to rely on us to use the equation that work is equal to a negative pressure times delta V. It says find the amount of work that is done on the surroundings when 1 liter of an ideal gas initially at 10 atmospheres is allowed to expand at a constant temperature to 10 liters. And so our initial, I'm going to put I for initial, was 1 liters, and it ended up going to a final volume of 10 liters. Again, this equation, this part of it, means that our change in volume, that is final minus initial. So what we're going to do here is we're going to look at work equal to a negative 1 atmosphere times our change in volume, which is 10 minus 1. That's a total of 9. And when we do this math, we will end up with a negative 90 liter atmospheres of work being done. So work was lost by performing, or energy was lost by performing this particular problem or this particular type of work. And the last part of this is going to deal with asking you some questions about something being sealed in a container and heated. So, all right, so for this problem, it's asking you a couple different things. What the system is sealed in a strong, rigid container, it's at room temperature, and then it's heated. Okay, so the thing you need to realize is that we are adding heat to this system. It doesn't say anything about the work being done. It just says that we are adding heat to the system. So we can assume that work is probably going to be 0. Okay, so for the last part of this question, it says predict whether W for this reaction is positive, negative, 0. We would predict that 0. No work is being done. However, if heat is being added, that means that it is a positive for the heat. My goodness. Positive for the heat. And if heat is positive and we're adding it to 0 work, then we would also assume that the delta E, and that's what the DE stands for. Instead of them writing delta E, that meant delta E. Delta E is also going to be positive as well. So Please make sure that you look at those problems. Again, I only did problems, problem 3, 4, 5, 6, and 7 are very similar to that. Take a look at these problems. If you have any questions, as always, email me or send me a message in the Teams app, and I'll be happy to help.